this is introduction class. Last time I give you the video, but I think I want to add on another video, which is this one is the video from my PowerPoint. So in this video we're going to learn on digital and analog quantities, just to increase your understanding on the basic about digital and analog. So without further delay, let us go to look into what is digital logic. So basically this introduction we already look it into our course information. In this course information we have basically about the conclusions or about introductions on digital logic. So here you can just go through on what is digital logic, but the main point is on our outline for this video. In this video we're going to learn first of all about analog quantities, and then followed by digital quantities, analog versus digital, and lastly on the analog and digital system. So I hope upon finish this video you will have much more understandings on digitals and analog quantities. Over here on the analog quantities we have the temperature versus the time. So we have time at this axis, x-axis normally is x, and this one is y-axis, which is on temperature. So how the analog quantities or signals look like. So this is the example. You can see the blue colors of the signal. And about analog quantities, let's go through. Most natural quantities that we see are analog and vary continuously. This is also that depend in the forum last time because I made the wrong answer for that questions. So basically I'm quite happy because you try to prove, you try to find the correct answer, and you learn it by your own. So now you know the answer is analog is continuous. As previous video also, I provide you with the key for analog and the key for digital, and you know that the key for analog is on the continuous. So what next? Analog system can generally handle higher power than digital system. So this is basically on the analog quantities. So there are examples also on analogs, which is time, pressure, and then also a power. So this is just a sample on the analog quantities. So let's move to digital quantities. So on digital quantities you can have over here temperature versus time also, but you can have the quite or slightly different type of graph. You can see here it is on discrete, which is it is not continuously. So over here there is discontinuous, which is not connected to each other, and this is called as discrete. Let's look into what is the meaning of digital. So digital system can produce, store, and transmit data more efficiently. This is another keyword, but can only assign discrete value, which is discontinuous, to each point. So same also in previous video I made that digital have a key, which is it is discrete. And then here is the example like bandwidth, storage, RAM, and also hard disk. So now let's move to our differentiations, analog versus digital. I give you last time the tables already. So there is a tables on analog and digital, and after this video also I will provide and upload many types of difference between analog and digital, because if you can list there is a lot of differences between analog and digital. So I will create one table and I will upload it into our e-learning so you can refer it later. So here we have over here the thermometer, which is this one is analog and this is a digital. You can have the same type of devices, which is you need to measure the temperature, but there is two type, which is on analog and also digital. So basically for analog it is base 10, which is decimal, while for digital it is base 2, or we call it as binary. So I hope this term you already learned, which is we learned it basically in our mathematics last time. So I hope you can still recall, but I think our next module also we will learn on this. So it will be represented by 10 different levels, because we are in 10 decimals or base 10, which is decimal, which is from 0 to 9. So we have 1, 2, 0, 1, 2, 3, 4 until 9, but there is only two different levels for digital, which is 0 and 1 only, or it represent as low and high, or sometimes in the get later on you can see also it is on or off. So there is two level only for digital. And here is you can see that analog system combinations of device that manipulate various representatives in analog form. Here is the graph, and this one is the digital system. You can see how the form of signals look like. So you have 0 1 0 1 value, and that high is 1, low is 0, and I think you can have the simple versus or differences between analog and also digital on this slide. So over here examples you can have a look, which is there is 5 stage basically, which is on the example sampling. So what we're going to do here on this sampling is going to do analog to digital, which is you convert the analog to digital. Later on you will learn on analog, which is A, D for digital, and C for converter, analog to digital converter. So here in the graph over here you have the analog and also digital in one signal. So now the next step you're going to do the first step of sampling. So over here this is the original analog signal. So the examples of original analog signal. What you're going to do is you're going to do the digital analysis of signal. So you're going to analyze all the signal one by one to get the basic overview of your digital. It's called as digital analysis of the signal from original analog signal. Next is on another next step is digital assignments of signal. So you will remove this original signal of analog. You're going to be like this. So all of this line will be removed and only left the digital or discrete signal. And lastly, you're going to get only the digital representations of signal. So this is just an example of sampling, just for your information on how sampling will be happen, because in next slide also you're going to learn on analog to digital converter, digital to analog converter, how it's going to be. So next is on our, there is also another example. So there is two type of sampling also. If let's say you take this one is lower sample rate, and you take only lower sample, which is this is the sampling for your digital, and this line is on your analog. So what is the result for your sampling is like this. You have this digital signal, while if you, let's say you do it faster sampling rate, which is it mean that more snapshot. So you take more snapshot in one single signals for the analog. So the result is much more smoother and more detailed. You can see over here, because you take the faster sampling or increase the frequency of sampling. So you can see your graph is much smoother and you can see it clearly. Let's say you were given only the digital signal, then you know, oh, this is how the analog look like. Compared to this one, if you were given only on the digital form of signal, you don't know what is the original analog signal look like, isn't it? It's quite hard to get. So this is just extra example. Now let's see on another example also on the devices. I already give also in last video, sorry. So over here I give you 10 example of devices which is related to analog and digital. So we have these devices, which is digital, which is analog. So I hope that you already understand and you can also differentiate which analog and also which digital. So over here you can see that this clock is analog, this phone, this clock is digital, this one is analog, and then this watch is analog, this television is analog, and this phone is digital. So you can see over here you have this phone, but basically it is different. Now let's look another example. Over here we still have a few, which is television, we have also phone, we have the display, and then display of your computer, and then your digital watch, and also clock. So what it is? So this television or display is analog, and then your phone, this one is quite different because this one is the digital, and then your computer is digital, this watch is also digital, and lastly this clock or watch, this clock is analog. So quite simple, isn't it? Now you can list the advantages. I give you some advantages of analog, some advantages of digital in the previous video, but over here I I give you another extra advantages of digital. So you have basically 10 advantages on digital. You can list and have more, I think, but over here let's take a look what is the advantages, which is ease of fabrications on IC chips, transmit more reliability, easy to maintain, to process, design, storage, greater accuracy and clarity, programmable operations, error correction detection, and lastly less affected by noise. So over here you can have the more efficient and reliability for, you can see over here it is more on data processing, data transmission, and also data storage. So this is 10 advantages or pros for digital. Let's move another. Okay, this one I list the disadvantages, which is for the con of digital. We have, if we got digital, we can have greater bandwidth, which is high bandwidth is required. Let's say over here we have 6 and then we have 20 hertz, so the bandwidth is quite big for digital. And second one is compatibility with existing analog system. So you quite hard for you to use analog current system that can be used on digital. And then digital product or devices normally short product half-time, which is lifetime for the product is quite short rather than analog. And lastly on the sampling error. So the sampling or quantities error is derived from analog to digital conversion process. So there is a sampling error on the digitals. Over here is analog and digital system. You can have basically a device which is include both analog and digital in one time. You can see over here many systems use mix of analog and digital electronic to take advantage of each technology. So the examples is, let's say you have the CD player and then you accept the digital data from the CD drive and then you convert it into analog signal for amplifications, or maybe you insert the CD-ROM, the CD over here into your CD player, and then you do the recording of your voices of any movie or maybe on the sounds of music, and then you turn it up and convert it into analog system to be the analog signal. So this is from digital, you convert it into analog but in one device. That's why it's mentioned over here there is mix mode, which is you have both analog and digital in one system only. As I mentioned that we're going to learn on digital to analog converter and also analog to digital converter. For digital to analog converter, we call it as DAC. So from here you can see that you convert digital sound from CD to analog. So this is your CD drive or your CD, and then CD is on the digital signal or digital form. So you insert to your CD driver, and there is a system inside it called as digital to analog converter or DAC. So it will change it into analog, which is analog reproductions of music audio signal. So then of course you have amplifier to make it sound more clear using a speaker, and it is a sound wave or analog. This is how you convert analog signals you convert digital signals to analog signals or sound. So next is on, before you go into analog to digital and also to digital, over here basically you have hybrid system. You can see that the audio CD is typically hybrid, which is you have analog and also digital system. Analog sound is converted into analog voltage, which is using your microphone and then your earphone and so on, which is related to microphone. And then analog voltage is changed into digital through the ADC in the converter or your recorder. After that, you're going to have the digital information is stored in the CD, and then you play it back to digital informations into analog by DAC in the CD player. So this is how the system change from ADC to DAC and etc. Still in this system, which is analog to digital and then digital to analog, how basically analog to digital converter and then digital to analog converter. Over here we see first on analog to digital converter. Let's say you have analog signal from your sounds yourself, and then you use the microphone, and there will be a process which is on the analog to digital converter. It's going to go to your music player, your radio, your computer, and etc. on the digital system. So this is your digital system, which is we're going to convert. Before you going into your digital system, you need to convert it to the digital first, because your computer cannot understand analog signal. Your digital system, which is your computer, only understand the form of digital 1010 like this one. So after you've been inside your digital system, there will be a converter called as digital to analog converter, which will going to convert your digital to analog signal, so you can have the sounds of your singings, of your song, of your speech if you are using the microphone over here. So this is how the processes look like it's quite long, right? But if you just saying something to microphone, then you can hear your sounds come out from the amplifier or from your speaker, so you can hear it directly. But inside of it, there is a process of analog to digital converter and also digital to analog converter. All these systems are built in. So basically this one is the video that I share on the YouTube. You can have a look into it by your own. So I think only that for this time. So next video I will upload also to our e-learning via my YouTube channel. So just stay tuned, because after this you're going to learn more on logic gate, your numbering system, and etc. Okay, thank you for your watching.